Hello, Ma'am, over here, and welcome to Module 3, wherein we will be focusing on the discussion of minerals. We have quite some objectives that we have to cover for this module. First, we will be identifying the common rock-forming minerals using their physical and chemical properties. Next, we will identify the minerals important to society, and then we will describe how ore minerals are found, mined, and then processed for human use. Quite a lot to cover, but I hope I can keep you interested throughout the discussion. Okay, so a quick recap on what we have discussed in the previous module. Today we have enumerated and described the 4 different Earth subsystems and how they are interacting with one another. Today we will be focusing on the geosphere part, or particularly the minerals, and how human beings, a part of the biosphere, relies on the minerals. Okay, so just a few reasons to keep you interested in our discussion. First, why do we have to study rocks and minerals in the first place? Well, they are very important to our society. Not only minerals, but also rocks and the energy sources we find within our geosphere. So, there are still multi-million mining companies that serves as the backbone of our society because our daily objects, technologies, tools have been made by minerals. So without learning how they are formed and how could they be processed, we wouldn't have a society like we do today. Next, rocks and minerals have led us to literally groundbreaking theories. So, the studying the rock types and their distribution had become the evidence to support the theory of the supercontinent called Pangea. So, if you can recall from I think elementary days, Pangea is what we call what our continents were before they broke apart due to plate tectonics. Now, how do we know that? Well, just by studying the age of the rocks, the rock types, and how they are distributed in different continents, we could trace how these continents had separated throughout the thousands of years. Next, we can use rocks and minerals to identify various hazards like volcanic hazards and tsunamis. So there are only certain minerals and rocks that could form under volcanic processes, and if you find that in certain location, that's an automatic sign or red warning that there is volcanic activity nearby. If there are also rocks that isn't in their normal shape, because rocks and minerals have their habit or normal form. If they are not in their normal form, then something forceful had deformed them basically, and that could be a tsunami sign, especially if you find them in cliff sides and rock faces. Okay, so diving into the discussion, let's start with our definitions. So what are the definitions of rocks and minerals and how are they different? So a mineral is a natural, solid, inorganic material of the earth that has both a known chemical composition and a crystalline structure that is unique to the mineral. So again, it's natural. It cannot be made by any organism. So not human-made, not made by any other living thing. Solid, so it cannot be liquid or gas. It must be inorganic, meaning no part of an organism is included or any excrement. So no poop, no bones, no teeth, no shells. Just natural material. Okay. Non-chemical composition. So the chemical composition should be specific and it should create a crystalline structure if you observe it in the molecular level. Now, what's its difference with the rock? When we say a rock, it's more than one mineral. If you combine minerals together, that automatically creates a rock under certain circumstances. So geomorphic processes, will be describing those. But again, rock is a combination of different minerals. Okay, since our discussion for this module is simply mineral, let's focus on that definition. So again, a mineral is natural, solid, inorganic, known chemical composition, and crystalline structure. Now, in the next part of this discussion, I will be showing you a few pictures, and you would need to identify if these are minerals or not. Ready? Let's start. Salt, mineral or not? Okay, so salt is a normal household item that we usually consume, but we should identify if it's a mineral or not based on the definition we have provided. So first, salt is natural? Question mark. Well, it is, because how is salt harvested? By the seaside. So when seawater evaporates, sometimes it leaves behind the salt component, and that's what we harvest. What we consume nowadays, that what we buy from the stores, is already refined just to make sure that it's clean. But originally, salt is natural. Next, it's inorganic because it's been made by normal earth processes, so it's not made by human beings or other living things. So it's still inorganic. As you can see, it's solid. We know its chemical composition, it's sodium chloride, and that in itself creates a crystalline structure. So salt is definitely a mineral. Okay, graphite, mineral or not? Okay, so graphite is one of the underestimated minerals out there, I think. So whenever we are looking at pencils and we say, oh, what's the mineral inside the pencil? People would often say, oh, lead. But lead is toxic. We could never use it as a material for a pencil. In fact, it was never used as such because it's toxic for human beings or living things in general. So what we actually use is pencil lead, and pencil lead is graphite. It's like a mix-up with the Greeks before, that's why they called it lead, but it has been graphite all along. Okay, so let's identify if graphite is a mineral or not. So it's natural. Okay, it's solid, it's inorganic. If we know its chemical composition, is mostly made up of carbon, and it creates like a sheet crystalline structure. So even if it looks brittle and not really like a crystal, again, it must have a crystalline structure, not necessarily a crystal, but just as a structure. And that's what we observe on graphite. Therefore, it's a mineral. Okay, we follow by diamond. Okay, so this is quite obvious. Mineral or not? Okay, so diamond is definitely a mineral. So it's solid, it's inorganic, we know its chemical composition. It's mostly carbon as well. It's solid, and it's obviously crystalline in structure. So definitely a mineral. Okay, so the term like the most precious rock on earth, it's not a rock, it's a mineral. So it's one of the most precious minerals out there. Okay, so just to get humorous, is mineral water a mineral? Okay, so obviously this is not a mineral. First of all, it's human-made and it's not solid. Mineral water is infused with water. Infused with minerals. So that's why the term, but this isn't considered as a mineral. So if water couldn't be considered as a mineral, then let's convert it. Tube ice, mineral or not? Okay, so this is also a giveaway. Of course, this is not a mineral because it's man-made. So we cannot consider this as a mineral. But how about snow? Okay, so let's go ahead and review the definitions. So is snow natural? Yes. Is snow solid? Yes, it is. It's ice particles. Is snow inorganic? Yes, it's made by climate or weather conditions. Is it we know its chemical composition? Yes, it's just water, H2O. And is it does it have a crystalline structure? Yes, and that's observable in snowflakes. That's why people love snowflakes. And therefore, snow is a mineral. Okay. Lastly, sand. Is sand a mineral? Okay, so if you will observe, this is the close-up, by the way, of sand. And if you will observe, it's made up of different things. So sometimes there are shells included in there, some small rocks that you can observe, some salt even included in there. So it's not a one material only. There's a lot of minerals included in the sand. So it doesn't even create a crystalline structure, so it cannot be considered a mineral. But you will definitely read sand being labeled as a mineral resource, and that's still correct. So sand is considered not a mineral but a mineral resource. Okay, so judging by this graph, it's showing you how the elements of the Earth's crust is distributed on the Earth. And you will see that it's mostly oxygen, some silicon, followed by aluminum, iron, so on and so forth. So simply by looking at this pie chart, you can predict what are our elements or our minerals are made of. So mostly it's made up of oxygen and silicon, and then there are some elements, rare elements mixed up in them. Okay, so again, let's review. Minerals must be naturally occurring, so again, made by natural processes without any living thing. It's inorganic, so no poop, excrement, bone, shells, and teeth. Homogeneous, so a uniform material. Has a definite chemical composition, and it's uniform all throughout, thus creating a crystalline structure because it's a molecular structure that repeats itself within the material itself. Okay, so those are the characteristics, the 5 characteristics of a mineral. So what if the material that we are studying does not reach all the requirements? So for example, just 1, 2, 4, and 5. It's not homogeneous solid. So that's where we call it, when we call it a mineraloid. So when we say mineraloid, this is any material which does not pass all the criteria. And we have some examples here. So for example, volcanic glass, or sometimes called obsidian, or I think in Game of Thrones like dragonstone. So there, it's not considered as a mineral because it doesn't have like an ordered internal structure. Then if you look at opal again, just by simply observing its surface, it doesn't create, like, it's not a homogeneous solid because it's made up of different substances, thus being labeled as a mineraloid.